Welcome back, Pre-Cal kids. We're on page 47 in our books, and if you don't know where your book is or you've misplaced it, you can always go on Canvas and write down the important stuff or print off the pages that you need, but the whole book is posted on Canvas in the notes section. It's a very large PDF file. So today we're going to continue our study of oblique triangles, which again means triangles that don't have a right angle. And when we were doing notes yesterday, we talked about the law of sines. And the law of sines was good for when we had an angle side, or an angle side angle, or even a side angle. Pretty much what you needed was a complete ratio. You needed an angle and the side across the triangle to do the law of sines. Today we're going to do the law of cosines. The law of cosines is for oblique triangles, but it's used for when you have all three sides or you have two sides and an included angle. And what that means is, we did talk about this when we did the area formula the other day, but we could have side A and side B and big C, and that is not a complete ratio. There's not two A's, two B's, or two C's, so we could use the law of cosines. I need you to know that this formula and this set of formulas are exactly the same. And all three of them where I'm starting right now, they're all equivalent. It's just that the formula has been rewritten to solve for whatever angle and side that you have. And so I'm just going to teach you a little trick real quick on how I remember this. The way that I remember this is that it starts and ends with the same letters, A and A. So if I have little a squared, then I have to have my other two sides, my b squared plus my c squared minus 2bc cosine, and you have to end with the A. Same for the other versions. The second one starts with a B, ends with a B, and then the A and C go in between. You don't have to memorize all of them. I'm going to be honest. The one that I wrote in white right here, that's the one that I know. These bottom ones where I'm drawing a yellow star, they're the same form as the top ones. The first one goes with the first one, except for instead of having the little a solved for, it has cosine A solved for. Again, I'm going to be honest with you. I just have this formula memorized, and then if I need to get to cosine of A, I can do the math to undo the rest of it. So up to you completely. And then at the bottom down here, we have this thing called Herons area formula. We're going to talk more about that when we get to the last problem on the notes page today, which is page 47. But Herons area formula helps you find the area of a triangle when you have all three sides, the side case. And the first thing you have to do is calculate S. You have to add up all the sides and divide by 2. And then you plug S into the formula up here to find the area. And we'll do an example of that. You're going to need a calculator, so please make sure you have one handy. And so I'm going to go ahead and start problem number 5 on the top of the page. So we have problem number 5. This is that I have a triangle with sides of A equals 8, B equals 19, and C equals 14. So I have a side case. And it wants me to find the angle measures. So I'm going to go ahead and do that. I'm going to draw a picture first. So I have A equals 8 feet. B equals 19 feet. Not very accurate drawing, and C equals 14 feet. So let's label our angles. Remember, angle A is across from side A, angle B is across from side B, and angle C is across from side C. And then I'm going to use my law of cosines. I'm going to go ahead and solve for, I'm going to do angle A first because A came first. So A squared equals B squared plus C squared minus 2BC cosine of my angle A. So I'm going to have 8 squared equals 19 squared plus 14 squared minus 2 times my 19 times my 14 cosine of angle A. This A is what I'm trying to solve for right here. So we'll get there. We got this. I'm going to rewrite this. I'm going to subtract my 19 squared over and my 14 squared over. So I'm really going to have 8 squared minus 19 squared minus 14 squared. And then you would end up dividing by this piece. So this would all be divided by -2 times 19 times 14. This equals my cosine A. So I'm going to go ahead and grab a calculator real quick, and I'm going to type what I'm boxing in yellow. Oops. What I'm boxing in yellow right here, I'm going to type this in my calculator just the way it's written. I'm going to press Control and then the divide symbol, and it's going to make that fraction thing appear on my calculator. I'm going to type 8 squared minus 12 squared minus 14 squared, and then don't forget this negative sign right here in the front, and then I will help you with the next step. So let's type it. Really quick, made a little mistake, and I realized that while I was typing. Right there, that should have been a 19. I have no idea why I wrote 19 squared. Okay, so let me type this in the calculator now. So when you type this in your calculator, you should get, oops, I don't have white. You should get this equals 493 over 532. You might have got a decimal, and if you got the decimal, you should have got 0.926692. That's fine. It's okay. So let's look at this for a second. This is what I have, but I need to solve for the A. So to undo cosine, we do the arc. So I'm going to arc cosine 493 over 532 in my calculator. And this is going to give me angle A. Before you do this, you need to check your settings. So to do that, you press the home button, and then you press number 5, which should be settings. And then number 2 is document settings. And it will tell you what angle measure you're in. So if you're in Scratchpad right now, that's not going to do you a lot of good. You want to make sure you're inside a document. And then press save. And then after you're going to save it, and then you're going to have to do a new document, because it won't apply that to the document you had to open. It's going to only apply it to the new document. So we go ahead and type this in our calculators. And as long as you're in degrees, you should get a degree answer out. If you're in radians, you can either convert it. But you should get, when you do this, that angle A, oh, again, with my white. Okay, let me erase that really quick. You should get that angle A equals 22 point, again, 3 decimals, 075 degrees. So here's my first angle, but I've got to find all 3 angles. So let me shrink this down really quick. I'm going to keep going. So here's the great thing. Don't get me wrong, law of cosines is great, and we use it a lot, but it is a lot more work than the law of sines. So once you have one angle, you have a complete ratio, and now I can go do the law of sines to find another angle. So I am going to do the law of sines. You can do law of cosines again. There's nothing wrong with that, but I find the law of sines to be a lot less work. So I'm going to have 8 over sine of angle A, 22.075 degrees, is going to equal side, let's do B, 19 over sine B. So using what we learned yesterday, I'm going to cross multiply, and I'm going to get that 19 sine of 22.075 degrees over 8 should equal sine of B. So what I'm boxing in yellow right now, I'm going to go ahead and type that in my calculator. Don't forget your degree symbol. Pretty please. So press your control divide, and then do 19 times, grab your sign under the trig button, then put your degree symbol, and on the bottom put 8. And you're going to get that sine of B equals 0.892572, blah, blah, blah. Again, just like we did over here, and we arc cosigned it, we're going to have to arc sine this. So I'm going to do arc sine of my answer, my 0.89257. Grab the whole answer. Don't chop it off yet. You'll introduce too much error if you do that. So you're going to press the trig button and grab your arc sign, and then you can press your control button and the negative sign, not the minus, but the negative sign, and it will grab the answer for you. And it should tell you what your answer is. I got B is equal to 63.198. So there's another answer. So we could do it again, or we can use the handy dandy trick. Triangles add up to 180 degrees. We know one angle is 22.075. We know another one is 63.198. So if we type this in our calculator and subtract from 180, we can tell that side C is equal, angle C is equal to 94.726. Nope, sorry, I rounded wrong. 92.727 degrees. And now you have found all the angles that you needed for this triangle. Okay, let's do the next one. So the next one says they gave us a picture, and they told us that angle A, which is going to be over here across from side A, is 105 degrees. So it says find the remaining angles and side. Okay, well, let's do little a first because we know it's angle. So here we go. We know that a squared equals b squared plus c squared minus 2bc. Cosine start and end with the same letter a. So a squared is going to equal 15 squared plus 10 squared minus 2 times 15 times 10 cosine of 105 degree symbol. So I'm just going to type this thing that I'm boxing in yellow, the whole thing, in my calculator. And I'm going to get a squared equals a magic number. So let's find out what that magic number is. So 15 squared plus 10 squared minus 2 times 15 times 10 times cosine of 105 degrees. You should the a squared is going to equal 402.646 and some change. So then I'm going to square root that answer. So we now know that a equals 20.066 centimeters. So there, that wasn't so bad at all. And now we can move on to finding the other angles that we need. So what we need to find still is angle B and angle C. So again, I'm going to go back. I'm going to do my law of sines. So I know that side A is 20.066 over sine of 105 degrees. And I'm going to do B, because I do think it's in alphabetical order, over B, and then sine, oops, hang on, didn't mean B. B has a number. B is equal to 15 over sine of angle B. Do the same thing, I'm going to cross multiply. When you do that, you should have 15 sine 105 degrees over 20.066. This is going to equal my sine B. So I'm going to type that in my calculator. So you're going to get that sine of B is going to equal 0.72262. And then again, we have to arc sine that. If your calculator's in degrees, I highly recommend it be in degrees. It makes it a lot easier. And you will find angle B. So you should get angle B is 46.225 degrees. And then I'm going to use my handy dandy trick again. 180 minus 105 minus 46.225 will find me big angle C, because that's the only angle I have left, and a triangle adds up to 180. And when you do that, you should get that angle C equals 28.775 degrees. Okay, one more problem to go. We got this, guys. Okay, so the last problem here is the Heron's area formula, and I'm going to write it down really quick. The area, this is called Heron's area formula. And it's good for the side case. Heron's area formula says that the area equals S times S minus A, S minus B, S minus C, where S equals all three sides added up and divided by 2. So on this problem, I'm just going to plug and chug some math. So this was our notes over here. So first I need to find S. So I'm going to do 43 plus 53 plus 72, all divided by 2. So when you add at the top, you get 168. Divide by 2, so you get 84. So there's my S value. And then to find my area is going to equal 84. When you type this in the calculator, you have to put the times symbol here. 84 minus A, which is 43. Let me clarify. You need that time symbol if you're using my little stow trick. But if you're not, and I'm not going to confuse you and explain what that is if you don't remember. If you're not using it, you don't have to have the time symbol. But I'm going to write it out of habit. Times 84 minus B, which was 53. Times 84 minus 72. So I'm going to go ahead and just type this in my calculator. And make sure you type the square root as well, because that makes you have the answer as soon as you are done. So take a moment, pause the video real quick, and do that. And when you do that, you should get that your area equals, I put my square root in there. If you didn't type your square root in the problem, you're going to have to square root your answer. 1,131.8. It rounds up to 2 decimals because it's 8869, and the 9 makes the 6 round up, so 8.7, and this was in meters, so meters squared because it was an area. And that is a little bit tedious, but it is Heron's area formula. Not too difficult at all. Hope you guys enjoyed the video, and I can't wait to see you and hear from you.